Hi, so in this last lecture on DevOps, we're going to look at some of the more non-technical issues related to DevOps. So in the previous lectures, I've already looked at what is CI/CD, what is IAC, what is CM, and how are they achieved, and the various tools used to achieve them. Okay, so that's more of the technical aspects of DevOps. Let's look at some of the kind of more generic, high-level overview of DevOps. So first thing is Agile, right? You probably have heard of this. Agile is a very popular approach to software development that's been around for probably 15 to 20 years now. Agile is an iterative approach to software development, which is used to replace the traditional linear software development lifecycle. So the idea of Agile is you want to get constant feedback from your customer or your end users, and you want your development team to collaborate with them to get this constant feedback and to be constantly releasing versions of your product for feedback from your customer. And the whole idea of this is so that when your customer changes their mind, and of course customers change their mind very, very frequently, you want to be able to adapt to their new changes, their new demands, their new requirements, and also of course to market conditions as well. So Agile involves a specific mindset, a specific cultural mindset, and of course you want to know more about this, I'm sure there are courses that will teach you about this, and also has a bunch of methodologies. The most popular methodology obviously is Scrum. Scrum is always associated with Agile. Then also there are things like Kanban and extreme programming and so on. So all of these are already been in use for a long time. So the question is, how does all of this relate to DevOps? Okay, how does this relate to DevOps? So just very quickly, the idea of Agile is you're going to work in sprints, right? So a sprint is a very short software development lifecycle where you design your code, you develop the code, you test the code, you deploy the code, and then once it's deployed, then the customers can basically review it, they provide feedback, then you review, then you go on to the next sprint, you develop some new features, you give to the customer to review. Based on the feedback, you go on to the next sprint and so on. So you develop your the features in your application through several sprints, okay, until you get the final working version. Okay, that's the basic idea of Agile, right? And there are also a variety of cultural aspects to Agile, like customer collaboration, responding to change, individuals and interactions, working software, blah, blah, blah. All these are your standard Agile culture or key principles. So how does all of this relate to DevOps? Okay, so the first thing is DevOps is actually, you can think of it as an extension or a complement of Agile. It's there to support Agile. So you don't have to think of DevOps and Agile in terms of opposition. So it's not like, oh, should I use Agile or should I use DevOps? Because they are basically two different things. Essentially, DevOps is going to help to make your Agile work better. So if your software project team is already using Agile, then DevOps is just going to make it work better. Okay, so they're both frequently used together in real-life projects. Okay, so let's see what are the key differences. Right, Agile is emphasizing collaboration between developers and the product team and end users. So what Agile and DevOps, Agile is trying to do is, Agile is saying, wait, there is a gap, there's a communication gap between the customers or your end users and the developers, and we want to bridge this gap, right? So we have more frequent releases of software, we get feedback from our customers, and then we work closely with our customers to see exactly what they want. That's the whole idea of Agile. So where does DevOps come into this is DevOps now takes the operations people into the picture. So typically, the customer will never ever talk to the operations people, right? So customers will never ever know things like, oh, Linux bash shell scripting or Windows PowerShell scripting. That is just so totally alien to them, right? So they don't know all about that stuff. People who know about that stuff, okay, probably are only developers. So operations people are generally out of the picture altogether. So now with DevOps is, like we already saw, it's trying to bridge the gap between the development team and the IT operations team. So now we're trying to bring the IT operations people into the picture. So now with Agile and DevOps, everybody is in the picture together, which means that there is less chances of miscommunication, right? So you're breaking down the gaps between these three groups of people with Agile and DevOps, and therefore minimizing or reducing the chances of miscommunication or slip-ups or misunderstanding between everybody. Okay, so that's of course good. The agile scope is only until application development is complete, right? So agile is really about developing software. So once the software is out, I don't really care about it anymore, or at least agile is not really concerned about the software. Once the software is complete, is developed, the customers are happy with it, that's the end of the story. However, DevOps is also focused on how to deploy the software properly. So on the production server, how to configure my production server to run optimally, how to make sure I can monitor the software while it's running on a production server, and so on. So that's DevOps, and of course you need to do that as well. And Agile is only, the sprints in Agile is only for development. So when you do a sprint in Agile, right? When you do a sprint in Agile, you are really only talking about development work. That's all. That's all. You talk about who is going to write what code. That's it. Finish. End of story. That's what Agile is about. But now when you take in DevOps, remember DevOps now, we're going to have to think about things like how to provision my infra, how to configure my infra, how to configure my database, what are the port numbers, what are the domain, how to set up my SSH. All these are IT operation stuff. But now you have to factor this into your sprint as well. So when you do your sprint with DevOps, you need to allocate some additional time to handle all these additional infra stuff. So the deployment onto the production server, the deployment onto the staging environment, the testing, running your automated tests, writing the testing code, doing unit testing, integration testing, system testing, UI testing, user acceptance testing. All this has to be factored into your sprints for Agile. Okay, so that's the way that you extend Agile with DevOps. Okay, so we're done with that. Now, sometimes you will see this thing, DevOps life cycle, and you see this diagram a lot when you see DevOps. So the idea now is there are different stages in the DevOps life cycle. Kind of like your software development life cycle, you also have a DevOps life cycle. And this DevOps life cycle basically corresponds to the different stages of your CI/CD pipeline. So we already saw you have a CI/CD pipeline, right? You have a CI/CD pipeline that does all these things. Okay, this is your CI/CD pipeline. Okay, all these things, these are your CI/CD pipeline. You have all this testing, right? So there are different things you need to do through all these phases of the pipeline. That is basically what we will call your DevOps life cycle. Okay, and sometimes you will see people partition it very neatly like this. So the development team will handle this part of DevOps, and the operations team will handle this part of DevOps. But in reality, the idea is if you are working in a DevOps team, everybody in the team should be able to write code, and everybody in the team should be able to do IT operations. Okay, that's the whole idea. You shouldn't have a silo. You shouldn't have only people who do IT operations and only people who do development. The idea in a real DevOps team is everybody can do everything. That's the whole idea. Okay, so the DevOps lifecycle phases, I've touched a bit on some of them, like CI I've already touched on. Okay, let's talk about some of the other things I've not talked about. So continuous development is just basically the development aspect of the software. So this is actually just basically your Agile sprints, right? In your Agile sprint, you plan for your software development. Who is going to write which feature in the application? Okay, how are you going to break down your application into smaller modules or smaller features? Which features are going to go into which sprints and so on? This is all just standard Agile Scrum methodology, so nothing new here. Okay, CI we already talked about. Continuous testing. Okay, testing is always a part of DevOps, but it's just stressed here. This is very important. You cannot have DevOps or CI/CD without testing. So testing is again important, super important, and testing must always be automated, because if you don't automate testing, nobody's going to do testing. Okay, so testing has to be automated into the CI/CD pipeline. Okay, deployment I already talked about. Okay, the last three parts is about what happens after the app has been deployed onto the production server. Okay, now the app is deployed on the production server, the app is running fine. Okay, cool. We still have to monitor the app. Okay, why? Because you see, the app is not guaranteed to always run fine all the time. Now, if your app is running 24/7 and your app is on a server that's going to serve tens and millions of customers across the world, you may not be able to take the app down. Okay, it's not like, you know, every end of the day you turn off your machine, you can take off your server or whatever. You can't do that for an app that is running, you can't do that for a server that's running an app that has to be available 24/7, right? You can't do that. So you have to monitor the performance of the app. How well is the app running? Is it slowing down? Can it handle the requests from 100,000 requests? Can it handle 1,000 requests per second or something like that? Okay, so all of this has to be done real time. It has to be continuous. Make sure that your app and the server, the production server is running on, is available. Of course, you also need to take feedback from your customers. This is a standard thing. You do this in Agile as well, right? At the end of every sprint, you're going to get feedback from your customers, right? So that's what you have here in DevOps as well. You're going to have feedback as well. That feedback will go on to improving the next version. And then, of course, the last part, continuous operation, just means that all these phases, you want to execute them in a integrated and continuous manner. So all of this just basically follows on smoothly from each other. Okay, and at each phase of the life cycle, you're going to have different tools, right? So for coding, you obviously will have an IDE. So your IDE could be Eclipse. You're working with Java. You can have Jira to do bug tracking or software planning. You can have Git for version control. Then you can have Ant and Maven or Gradle. This is actually basically Java build tools. This is to do the build process, compilation, okay? Then for testing, you can have Selenium, you can use JUnit. Then for the automation server, you can use Jenkins or Bamboo. For deployment, you can use your IAC or CM tools like Ansible, Chef, or Puppet or SaltStack. Then for monitoring your app while it's running, making sure it's running properly, you can use Nagios, Splunk, Sensu, or New Relic. So you have a variety of tools that you can use at various phases or stages of the DevOps lifecycle. Okay, so obviously there are lots of things to learn, right? So this is basically what we call the tool chain, the DevOps tool chain. So if you hear this term DevOps tool chain, what does it mean? It means we're talking about all these tools that you're going to use at different phases of the DevOps lifecycle. So you can see there are already a lot of tools. I actually haven't, mentioned all the tools. They're actually, like for IDE, you have so many kind of different IDEs. For build here, I only talk about Java. Build, if you're using C#, you're using .NET Core, you have package managers. That also is all part of the build process. So you have many more options here. And then of course for testing, if you're using C# or .NET Core, you also have your own testing framework and so on. So you have many possible tools you can use. All of these constitute what is called the tool chain. All right. Now, if you're working with a tool chain, you have two approaches, right? So this is the less common one. This is the more common one. I'll talk about the less common one. The less common one is you can go for a commercial standalone solution, which actually has tools that apply to the entire stage or to all phases of the DevOps lifecycle. So rather than take all these things, now most of these are all open source projects, right? So rather than take all these open source projects, you can go for a commercial provider that provides a complete solution for the entire lifecycle. Okay, so that is good for newbies. So if you're new to DevOps and you want to start a project quickly using DevOps, that's good, that's fast. The problem is, this is the main problem, is after you have done a very basic project and you want to start using more advanced functionality, you will realize that an all-in-one tool chain is not going to be good enough because it would just be very basic. Okay, and also most developers who are competent, they usually have their own preferred tools. So you will see that most senior developers, they will only like to use certain IDEs, they will only like to use certain build tools, they will only like to use certain kinds of version control system, and so on. So most teams that are very professional, they already have their own preferred tools. Most of the time, these are open source tools. Okay, so all-in-one tool chain is not so popular. What people do these days is a customizable DevOps tool chain. So that means you just go and pick whatever tools you like and you try and get all these tools to play with each other. And this is the major drawback of a customizable DevOps tool chain, is that you can get the best of the best. You can get a good mixture. You can get the best version control system, you can get the best monitoring tool, you can get the best build tool, you can get the best CI server, you can get the best of the best IAC, but then you have to get them to play together. You have to get all of them to play together, and that can be complicated. Okay, The good news, however, is that most of the main market players in this area are all already playing with each other. So what I mean, like for example, Jenkins is a very well-known CI server. So Jenkins itself, as you see in my later lecture, Jenkins itself has already hundreds and thousands of plugins that will allow it to work with all of these other tools. Okay, Ansible is a very leading contender in the IAC CM space. Okay, so in terms of automating the provisioning of your infra, Ansible is right there at the top, and Ansible can also play with Git, with Eclipse, with all these build tools, with Jenkins and so on. So what it means is that all the top players in the different areas, IAC CM, build tools, CI servers, monitoring tools, all the top players in all these major areas, all of them can play with each other very well because they are all open source projects and they all have to work with each other anyway. So you don't have to worry too much about this because of the open source community is already moving in that direction to try and get everything to work together. Okay, then we talk about what are the best practices for DevOps, right? So what are the best practices? Number one, obviously, is you want to get everybody to be involved, right? So we already saw the whole idea of using Agile together with DevOps is you want to get the customers to be involved with the developers, and you want to get the developers to be involved with the operations team. So just generally, you want to get everybody to be involved as much as possible. You want to make use of Agile methodologies, which I already talked about in detail just now. Then the other thing, automation. Everything must be automated as far as possible. Of course, not everything can be automated, right? You can't get your code to be automatically written, although I think now there's AI that can actually automatically write code nowadays, so maybe now you can automate everything. But as far as possible, you try and automate everything so that you will never forget anything. If it's automated, you won't forget. Most of the time, testing doesn't happen because people forget to automate it. People forget to test. If you're a developer, normally what you do is you compile your code works fine, you go home, you forget about testing, right? So if you don't automate your testing, then you're not going to do it. That's it. Okay. Then you have to monitor your pipeline. There's something called the 3 pillars of observability. You want to monitor the logs coming up from your server, from your apps. You want to trace your application logic, okay, and you want to have metrics of resource usage, how much CPU is being used, how much RAM is being used, and so on. You want to use what is called a microservices architecture, right? So nowadays, most companies like to deploy their apps on the cloud. This is called cloud native apps. Okay, so 15-20 years ago, when people design apps are meant to run on a server in a company's local infra. That is just generally how it was. Nowadays, at least in the past 5 to 10 years, most companies, they are designing their apps to run on the cloud. This is called a cloud native app, right? So from the start itself, your app is designed not to run on a company server. It's going to run in the cloud. It's going to run on AWS, GCP, Azure. For this kind of cloud native applications, there is a particular architecture style called microservices. This one, we can even do an entire course on it. Microservices basically takes a large complex system, breaks it into smaller services, and then assigns a team to each service, and all these services will just work with each other to accomplish some complex functionality. So DevOps is always used with microservices. You will see these two terms are always used together, DevOps and microservices. And then finally, this is actually the most important aspect of DevOps. It's actually the culture, right? So the culture is about collaboration, communication, and transparency. It's the same thing that you have in Agile. So if you're already familiar with Agile culture, these are the principles of Agile culture. If you're already familiar with Agile culture, then DevOps is pretty much the same. The idea is very simple. You just need to talk with each other, right? So the developers in the team, you need to talk with each other. That's the whole idea of CI. CI is forcing every developer in the team to talk with each other all the time. Okay, maybe not like every single hour, but at least once in a day you talk with your team members, right? You need to know what everyone else is doing so that when you integrate code, you can resolve your conflict. You need to talk with the operations team. You need to know how they're deploying their servers. You need to know what are the problems they have with the servers, blah, blah, blah. You need to talk with your customers. You need to talk, well, basically, you get the idea, right? And then you try to avoid blame for failure, adopt a growth mindset. Okay, this is very important because when you transition to DevOps, it's a real pain in the ass. Why is it a pain in the ass? It's because you have to learn a lot of tools, and you have got to get all these tools to work with each other. So it's really a steep learning curve. It's going to take a long time to master all these tools before you can get up to speed with your DevOps CI/CD pipeline. So because it's a steep learning curve, everybody is going to screw up. So if everybody is going to screw up, try to stop blaming each other when you screw up. Try to learn from your mistakes. All right. So that brings me to the end of DevOps. So this is a very comprehensive coverage of DevOps.